how many of you have done something as simple as try to open an Excel notebook that contained millions of lines of data? It's impossible, right? Next to impossible. It locks up your whole computer. So use Excel with caution. Don't open up large data sets, right? Often better than equivalent commercial tools. This is it's a very true statement, and I hope to convince you of that over the next few minutes and next few days for sure. For one, you're all using open source software every day. I mean, every time you log into a web page, that web page is being served by a Linux web server, right? Every single one of the top 500, fastest computers in the world, supercomputers, are Linux machines. Anyone who's done anything in Linux is using open source software. Linux is the most used open source software project in the world, largest in the world. And so of course we're all using that, at least that. Even under the hood of many commercial software packages, there's lots of open source software. Like for sure, all of the basic linear algebra that is done in any kind of physics-based simulation tool, they have libraries underneath, BLOS, basic linear algebra services, LAPACK, things for doing solving linear systems of equations. Those are all open source software that have very liberal licenses such that commercial software is able to incorporate it in them. So we're going to use a lot of open source in this class. In fact, every tool that we talk about is going to be open source. And what that means for you is that you'll be able to use these things immediately in your day-to-day work. And hopefully will convince you that in many cases, they are of better quality than equivalent commercial tools. And, over the next few weeks, as we see some more kind of software engineering, when we talk about unit testing and continuous integration and other things, and then you go to GitHub and you look at these open source packages and you see the amount of testing that's done on them and automated testing that's run upon, every single character of code change. Most commercial software is not held to that kind of quality standards. And so, I hope to actually present some evidence that says, that shows that that open source software is of better quality than commercial tools. So, why? Quality, security, reliability. Given enough Given enough eyeballs, all bugs are shallow. This is something called Linus's law. So Linus is Linus Torvald. He is the original creator of the Linux kernel, right? So Linux is sort of a conjoined word of Linus's name, and the word Unix, right? So Unix existed before Linux. Virtually all Unix machines are Linux machines now. There's some form of Linux kernel, right? So the idea here is that by being open source and having thousands of people use it, interact with it, it doesn't take very long for bugs to come to the surface. And as long as you have an adequate system of documenting and fixing those bugs, then the quality of the software will rise. And it's really this idea combined with quality version control software system. We'll talk about that later. And in fact, it was really trying to manage the thousands of contributions that were coming in to the Linux kernel that caused Linus Torvalds to also write Git, the version control software, the underlying namesake of the website GitHub, which we'll talk more about later. So Git is a version control tool, also written by Linus Torvald, used to manage the Linux kernel project. And we'll talk more about it when we talk about Git and GitHub, but it really is the ubiquitous kind of tool for version control. And hopefully you'll be using it regularly after this course. Modern software engineering practices, what I mean by that is things like automated testing, continuous integration, automated documentation systems, other things like that. And, notebooks, the use of notebooks for reproducibility and documentation, other things like that, all kind of fall into this modern software engineering practices. And of course, modularity. And in the open source world, we often just build on top of other pieces. Even if we set out to do our own open source software project, we're often just building on top of other packages. So for example, like I mentioned earlier, BLAS and LAPACK, these are like the most fundamental and core linear algebra services available. And so, no one really these days goes through the extent to write their own like matrix vector highly optimized matrix vector product routines. You're just going to use BLAS and LAPACK, which are written in assembly, and nothing will be faster than those. In fact, if you're using an Intel machine, there's a software which has all the BLAS and LAPACK capabilities called MKL. It's Intel's math kernel library. Now, the math kernel library is not, in fact, open source, so maybe I shouldn't be talking about it here under open source, but it is freely distributed. And but the reason I mention it is, again, it's distributed by Intel, and because they have their own expert knowledge of the hardware, the software that's written into MKL really can't be any faster. It uses internal knowledge of the hardware to make those type of matrix vector or matrix product operations as fast as possible. And so, if you're ever doing any kind of linear algebra, you really should be using some of these fundamental libraries. Of course, it's all wrapped under the hood from Python. We'll be using them and we won't even know it as we go forward. So this idea of modularity, building upon the tools of other people so that we can write less code and get more done, is another reason for using open source. Lower cost of ownership. Free is in speech, not beer, right? So what we mean by that is that, somebody had to write the open source software. So it's not completely free because someone's labor is tied up in it no matter what. It's not free like beer. But what we mean when we talk about, free with respect to open source software is freedom to use it however you please, right? And it's one of the reasons we try to only use open source software in this class, even right down to our learning management system here. This learning management system is based on something called Jupyter Lab, which we'll talk about in more detail later. But this itself is open source, and you can install this same exact environment on your own computer. That I can think of, we do not use any, or there's not one piece of kind of closed source software that we'll discuss over the next few weeks. And so everything you do here, you should be able to reproduce on your own, in your own environment. And of course, you'll have access to our learning management system for quite a long time, but at least a year. But nevertheless, you can reproduce all of this in your own environment as well. So that's what I mean by lower cost of ownership. This one might surprise you, but community. It's actually one of the things that makes Python so strong. And if I haven't talked about Python, let's go do I like to just do this live. Let's go do a Google Trends search and look at Python data science. And let's expand the region, so the range since 2004. So, if you look at Python data science, and I put the data science in there because, well, let's not for a second. Let's just remember, how many of you got started programming using, say, MATLAB? Can you give me a thumbs up or a yes or something, a hand and head nod? Let's just do a comparison of Python versus MATLAB since 2004. So MATLAB's pretty steady. And by the way, you see how, particularly with MATLAB, appears to be very cyclical. nice tools built into MATLAB to do data science, but virtually no one does it. And even the same thing, we could probably, another popular language for data science is R. So it's a statistical programming language. So if we look at R, I think you're gonna, well, that's actually surprising. I thought R would be a little closer to.
Hey, John, I think it might be putting a space between data and science.
Negative. It is 2 words. I don't know why I wrote it like that. There we go. Apologize for that. I don't know why I wrote that. But yeah, so this is kind of what I was expecting. Again, no one really does data science with MATLAB. When I say data science, I mean, again, everybody who uses Excel is doing some kind of data science. So maybe I shouldn't be that critical. But let's say machine learning. No one really does machine learning with MATLAB, even though there's quite a few tools built there. A lot more people use R, and of course, the popularity of Python is really high. And it's one of the reasons that, this is really the reason that we do advocate Python, because there are other good languages. R is a great language. Not such a fan of MATLAB because of the closed source nature of it. But nevertheless, returning to this bullet, community. What that means, what the fact that all of these people are, I mean, obviously these are Google Trends, so it's like search queries. So it's basically people searching for things related to Python and data science. But nevertheless, part of the reason that we advocate for Python is because of this aspect of community. So the more users of a language there are, the larger the community. And what that means for us as learners is that there's more help available. So if you go to Stack Overflow is, if you don't know what it is, it's a website for asking questions about coding. Usually there's quite a bit more there, but if you go to Stack Overflow and you were to look at the tags, maybe we have to go to a question. I don't recall it off the top of my head, but if you were to go and look at the tags, here we go. This one I meant to do, Python. There's, for Python, there's currently, for Python 3, there's currently like 132,000 questions on there. For pandas, which is something, it's a Python package we'll learn about later, 127,000 questions on Stack Overflow that have been, most of them have likely been answered already. So if you need help learning Python, the larger the community, the better it is for you, right? And also, Python is a general purpose programming language. It's one that, we'll use for data science and machine learning, but Unix system administrators often use it for doing system administration tasks, things that they might have formerly just used the bash shell or something else for. And I'm just making the case that the community being larger leads to more help ultimately. And by the way, if you don't use Stack Overflow, I mean, I tell my students in class, and often when I'm teaching program, I often won't give them all the information. I will purposely, in an assignment, leave out something and force them to go to Google, force them to go to Stack Overflow. I've been coding for, daily for close to 20 years. And for at least 7 years of that time, it's basically my job. Did it all day, every day. And, at any given time, you'd see, on my computer screen, you'll see a terminal window open, you'll see a Jupyter Notebook open, and you'll see Stack Overflow open. I mean, I'm on there as much as anyone, and I've been coding a lot. And it really is just an essential skill. It's part of learning to code, is learning to search Google quickly, search Stack Overflow quickly for answers. So what that means is learning the correct keywords. So if you just type Python in the Google chat in the Google search bar, you're just going to get pictures of snakes, right? But if if we teach, if you type, say, NumPy or, Python pandas, then in that case, you're going to get something a lot more meaningful. And so, it really just is an essential skill, and don't feel bad or feel like, that you're not an adequate programmer if you have to search Google and search Stack Overflow a lot to find answers. We all do it. It's part of it. And that's part of why we advocate Python, is because Python for sure has the largest community beside any other language except for possibly JavaScript. JavaScript being the language of web pages. So, and I think the point I meant to make when I went to Stack Overflow is to say that the last time I checked, Python was the #2 tag in all of Stack Overflow. Again, JavaScript being #1. And it's quickly approaching JavaScript. The last thing is build a real resume, right? What I mean by that is, this is another thing I tell my students, like, no one cares if you send them a PDF of your resume and at the bottom of that, it says that you know C++. No one cares. Not today. You'll never get hired at any tech company doing that. And I know you guys aren't looking to get hired anywhere, right? You're just looking to upskill at your job at Noble. But nevertheless, when you work with and contribute to open source software, when you follow good software engineering practices, when you embrace this idea of openness so that you have fewer bugs and a lower cost of ownership and a community, what you also do as a byproduct is you build a real resume, right? And what I mean by that is, again, I showed my GitHub earlier. If you go to my GitHub, again, you can see, in this kind of grid view, all the commits I made. But let's look at something more specific. You could also go to my repositories. You can click on any one of those repositories, and you can see, the code that's in there. But let's go to a piece of code that I've contributed to over the years called Paradigm. This was a code we started when I still worked at Sandia, and it was open source in 2012, and we've been maintaining it on GitHub ever since. And these are the kinds of problems that we solve with Paradigm. I actually use it in my research at UT to do hydraulic fracturing. But here you can see it's a general purpose fracture predictive code. So you can see here like some simulations. This was a cylinder that's been exploded, fragmented into many pieces. So it's very good at doing computational fracture. And so if you go out here to the contributors and you click on it, right here, you can see that I'm the 4th largest contributor to this code base. I've written 61,000 lines of code, and I've deleted 32,000 lines of code. Of course, most of that was some time ago, 2012, 13, 14, and then maybe a little bit in 16, and a little blip out here a few months ago. But what we can do, you can even go further than that if you're really interested. If you were to, sorry, didn't mean to do that. But if you were to actually look at the commits I made, you can go in, you can see every single commit I made to this code base. Commit meaning like a snapshot in time. So, there's a message there, but if you go in here, you can actually see the code that was changed. So this is C++ code. And so over here on the left was the original source file, and over here on the right was the changes I made and committed to the repository. Everything is in the open. Every piece of work that you do when you follow these practices is in the open. And this is the stuff that people care about, if you're looking to make a career change. This is the stuff that gets you hired at Google and Amazon and Facebook, okay? And I hope that one day we can say the same thing. I hope, my goal, my vision, part of my desire and sort of what motivates me and part of the reason I wanted to start Datum and teach is I really love to see a culture change in the oil and gas industry. We have so much opportunity that if we would just collaborate with each other, work in the open on a lot of projects, the real value of most large companies is in the assets that they're saying they're in the ground. It's not in the crappy software that they're writing. So I really hope to see a day when we can collaborate on software, work together, and let's really focus on efficiently getting the real, where the real value is, the stuff that's in the ground out. Of course, I should caveat that when today's oil prices, maybe the real value is not what's in the ground. So kind of last thing we're going to talk about with respect to open source and Python is this, the Python data science ecosystem. So you might hear me say that, you might hear me use things like PyData, Python data science ecosystem, those kind of words. And what I'm really talking about is what the things you see here, the individual third-party models, of course, Python itself, but also the models that we use to build software around them. Jupyter Notebooks being a core functionality of that. All of these we'll learn in this class. I mean, GitHub is not really related to Python, but it's where we store our Python code and was something we will cover here. All the rest are Python libraries. NumPy, this is our core numerical computation library for doing array computations. Pandas is sort of our drop-in Excel replacement. SciPy, this is where all our numerical algorithms like root finding and interpolation and integration routines are contained in SciPy. Matplotlib is a plotting library for making production quality plots. Bokeh is another plotting library really targeted for web-based and streaming applications. Panel is a dashboarding application built on top of Bokeh. And of course, scikit-learn is the workhorse machine learning framework, probably the biggest, most used machine learning framework in the world. And those of you that took Dr. Perch's class got a little bit of exposure to it, and we'll be doing some more in this class as well. So we're actually not going to write a whole lot of Python code today, some review, but before we go on and talk about something else, I'd like to go ahead and ask your Python expertise. So